So I'm going to talk you through some of my adventures in blockchain. The focus is upon what good is, value, meaning, visibility and supply. So in 2017 I did a special issue, The Future of Money and Further Applications of the Blockchain, and this is the overview paper that we produced. There are 10 studies in my special issue, but these are some of the key takeaways. So Scott found 5 factors influential in determining future use of blockchain technologies and distributed collaborative organizations around trust, remittance, encouraging disintermediation, political influence and global commerce. White produced a study of DLT as an innovation. He found 28 core papers and 7 potential application areas of blockchain, which we can see in the table there. He then did a Delphi study with a small group of experts, and they added further studies and they ranked where they thought possible applications may be. This is quite interesting because it might inform long-term studies, because we can reflect back on where we are and where people thought we were going to be. Herian's work examines law surrounding trusts, using legitimacy of trust and how that informed and how a DLT might challenge established law in that area. Kewell writes on a future imaginary on Bitcoin as a dominant force. Maybe she was right, because it's worth around £14,500 today. Then there's 2 papers on governance, looking at reality at once more complex and more resilient than we credit it for. Chains are hampered by lack of consensus, and again, power. We talk about distributing power using these distributed ledgers, but what we see in blockchain is instead a focus of power within expert groups. Part of the reason I did that special issue was because I'd written a couple of pieces around blockchain for good, and I was looking for a community, and there wasn't really one that I could publish with, so we came together and produced the SI, and that's led to a number of different papers on this area of blockchain for good, and ultimately I'm editing the Frontiers Journal on that space. So really my work asks the question, what is good? So just some background theory here. In the Republic, Plato proposed a dyad of characteristics for good. Things could be good for their own sake, intrinsic goodness, or enacting them leads to intrinsic goodness, and those are extrinsically good things. More said that actually goodness must always be subjectively evaluated. There is only the extrinsic. So something can only be good if you perceive it to be good. It can't be good in and of itself. But this raises a question: if you don't perceive that you are good, could you not still be good? Most philosophers still hold to the construct of intrinsic goodness. And Frank Kenner identifies common intrinsic goodness. He's in his book, he's got a list, truth, knowledge, beauty, aesthetic, freedom, peace. These are the sort of things that he says, well, these are intrinsic or inherently good in and of themselves. The Blockchain for Good 2017 paper asks what is good. We look at value as a means of measuring what is good, money, experience, learning, are measures notionally of goodness. Many papers have been claiming blockchain for good by resolving long-standing obstacles to profitability, which is a focus on value as financial worth. But that's really, for me, that was just innovation. We define good more in terms of tackling global challenges, philanthropic work, tackling sustainability agendas through the UN Sustainable Development Goals. You do still need to capture that financial worth, otherwise your business isn't sustainable, but I think it needs to be bigger than just the money. So the work builds upon affordance theory, and we define affordances. It's the properties of the thing, what it can do, what it could possibly be used for, any artifact, what can it be used for? So when we look at blockchain, what can we use it for? What does it afford? Can blockchain be good? Again, we're asking this question. In Blockchain for Good underlying, DLT enables digital value transfers between unknown entity. And these are some of the properties, that maybe doesn't require a trusted third party, but what about the DLT provider? Surely they are a trusted third party. It ensures privacy, but that's privacy in a glass house. You can see every transaction in a public blockchain at least. You're enhancing information exchange transparency potentially, and you'll make trust obligations easier to discharge between transacting parties. These are the properties that we have. So DLT really represents a novel way for humans to exchange value. We're changing the social constructs and changing the way the internet might be used towards an internet of value, perhaps. We consider examples. Coloured coins could be presented as good, where we've seen Islam coins where you can only buy things that support the Islamic faith. But that raises questions: who's engineering the coins and whose value or values are embedded within those coins? It seems a little controlling. Land registry and artifact provenance are examples, and financial inclusion. Many applications we noted in this work actually require stable national governance and some form of identity in order to enforce any outcomes of stuff done on the blockchain. So it's sort of, we find paradoxes, if you like, and we probably need to explore and write about those more in our time within Decade. Ultimately, blockchain for good is an emergent phenomenon. It's not the original idea of blockchain, but we've seen an awful lot of work on ideas around good. In our paper Perspectives on Good that's going to be published shortly in Frontiers, we suggest researchers need to frame DLT applications in terms of value and good much more clearly. You'll see lots of papers claim it. They don't really dive into any philosophical view of good or value creation. Kranzberg's first law of technology: it's neither good nor bad, nor is it neutral. We're responsible for the ethical framing, applications of new technologies, so obviously that's going to be part of the centre's work. Many B4G papers do not consider good at that philosophical depth. Value is not ethically framed. There's an assumption that all progress is somehow good. Value creation practices location and slippage. So here's the sort of model that I created. You might have a machine level, a microdyad, a situational level between two people, or some forms of triads, or interactions between people or networks, maybe societal level at the top there. And value can be created at any of those levels and exchanged between those levels, and that value may be captured at a different level. So if we think about at the micro level, somebody does something for somebody, they get paid. Maybe that pay, they work for a business, so the business takes some of that value. And maybe there's a very high tax level, so the top level, the societal level benefits. So you can see how all that flows through. We should consider technology as part of the broader service ecosystem. So this is this image does represent that ecosystem, and flows of value go up and down as well as across at each level, and that's how we really construct that thought piece. In this paper, Visibility of Digital Art, we look at blockchain as an ownership layer on the internet. What we mean by that is, how do you own and transfer digital art? Again, this was a paper I'd written. We were looking for a home and it became part of the special issue. Some background to this work. Well, in 2014, the online art market was worth 1.57 billion and they expected it to be 3.7 by 2018. I checked and the last figure I could find was 4.64 billion in 2019. However, it's a lot of money, but 50% of purchases are less than £100, so this isn't mirroring the physical artwork. Now, theoretical contribution of this particular paper builds on supply chain visibility, and visibility is the availability and capability of information to inform action. So how can you work from that data and actually do something? What we find is buyer-supplier information is often asymmetric, so we get power imbalance and often deception due to conflict of interest. So Google allows you to search and view any image, but it doesn't block any copying. The PowerPoint does the same thing. It gives you an option whether you want to have copyright enforcement or not. YouTube and SoundCloud may pay royalty, but their whole contractual process has very little visibility, and we understand that the issues that those services face. The effectiveness of law in the digital world has been limited. The laws to protect digital art are very strong, so new legislation isn't required. Enforcement's really the problem. The value of art is driven by provenance. Now, provenance provides the history, the authenticity by establishing ownership of a piece of art over time. The Mona Lisa, probably the most valuable work in the world, has a detailed 500-year provenance. Now, provenance is built on what's called catalogue raison and auction catalogues. The catalogue raison are created for famous artists. They're a ledger of all the works that artist has ever produced. If your work is not in the catalogue raison, then its value is massively diminished because it's not recognised or attributed to that artist. The catalogues are held or maintained by some pretty powerful groups, such as the Wildenstein Institute. They look after the Monet and Gauguin catalogues. You can see an example of them there, and there's the Van Gogh one as well. So whoever owns a catalogue really has power over value. The case study of a scribe presents the solution in two parts. It's the where is and the my stuff. My stuff registers the work on the blockchain. It allows for editions of a single image. The ownership is really down to the private key. Whoever owns the private key owns the work. The ownership is tracked as it changes over time. Transactions are public but pseudonymous. It's really down to who owns the key infrastructure. The where is bit is if you've got the work's hash, you can find it on the blockchain. But there's an intelligent image match. It's a bot that crawls, displays how many copies of the image can be found on the web. It finds images that are similar, and when it first appears, then it gives the owner options. You can either ignore the use, you can request a fee, or you can issue a takedown. So I did a book chapter with Alex Kalamov looking at supply chains, visibility, blockchain, and human behaviour. Human behaviour can hinder adoption of technology. If we look at simple buying and selling in supply chains between companies, even simple purchases can be quite complicated, requiring lots of different communications. Maybe there's a request for quotation, then you're issuing purchase orders, then you're maybe supplying the part. Does it get logged? Will you ever get paid? A lot of it relies on mutual trust. To alleviate the noise or the headache of trying to deal with all those transactions, large firms may introduce an intermediary to manage their purchases. That adds another layer of complexity and possible more delays or errors. The suggestion is blockchain can alleviate the problem by removing intermediaries and providing that ledger, that list of transactions. In practice, human behavior can lead blockchain into further complication. Again, more noise, monopolization, dominant miners, all these common problems. Bias is a key problem. People become overconfident, and there's habituation, there's conservatism, and this paper really starts to look at human behavior and how it's getting in the way. What the suggestion is, you need to de-bias to implement change. So the process steps recommended as identify the biases you're faced with, what are the alternatives for de-biasing, and then once de-biasing techniques are deployed, let's monitor it and see how effective we are in de-biasing to allow us to innovate. And you can see this is potentially interesting because any deployments or barriers we might use, we can follow this process and say, well, this is what we faced and this is how we implemented. My current work is really interested in supply chain visibility And this is a summary of the paper we did on food supply chain. Supply chain visibility is the use of data to understand what's happening. Traceability is a sort of a step backwards. That's the ability to trace back to origin any item through records. Visibility allows you to access data to see into the supply chain and drive action. Now, blockchain is a useful part of the system. Current supply chain management use cases of it are quite few. Most publications we see are conceptual at the moment. Blockchain helps create trust in the product and process. Customers are demanding evidence of provenance of food products, and that's driving the sort of implementations that we're seeing. In this paper, we have 4 case studies that utilize blockchain. One's for fish, one's for grain, one's for wine, and the other's for baby food. Going forward, we have others on wine and chocolate coming out soon, I hope. Supply chain visibility can help reduce potential labour abuses or modern slavery. We're looking at location, the people, the equipment, and blockchain really helps making it much more difficult to conceal those sort of things within the supply chain. Blockchain holds the processing data, and that's used as evidence of veracity for audit. It helps consumers and auditors see products or processes are as they claim, protects the products against counterfeit, provides evidence of process. If you look at the can of baby food there, you can see there's an RFID tag on it. What that does is you can scan it whenever you like. Every time it's scanned, that's logged, and it also shows you where that can's been. And then if the can is opened, that tag is broken and it shows the product is no longer viable. If a consumer scans the tag, then it shows them a picture of that actual can taken on the production line. So blockchain systems help create this perception of trust in the process and thus trust in the product. Systems validate supply chain visibility, but end-to-end visibility and digitisation is the real challenge. All of our cases highlighted the need for end-to-end digitisation. It's easier for digital goods, but it's quite difficult for physical products. You tend to have holes. There's a proposition that actually it's impossible because of those significant challenge. Whenever you're having manual input of data, there's opportunities for fraud. If you're labeling or putting tags on something, you can swap those labels around. Kirch's proposed that blockchain removes the requirement for tagging. That might be the case in some instances, and we've got a case example we're working up now on DNA, where we're extracting DNA from chocolate and using that. So you don't need a tag. But by and large, at the moment, blockchain systems rely on some form of tagging to bridge the physical digital world, be that RFID, QR, barcodes, that sort of thing. So the system's main weakness is at the digital physical boundary, and that's something to be overcome. The hub of all things is a personal data platform that we built. The challenge here is to develop a personal data platform which gives individuals back control over their data. Central to the Hub of All Things project is the creation of what we call personal data accounts. Now, these are data accounts which are controlled by the individual. You hold your data in the cloud. Now, this account might be created the first time you log into an app, but when you log into another one, you might say, well, look, I've already got one of these accounts, and it connects to your personal data account. Then any data that's created is held in your hat, and it's shared via the apps with your permission. So you can reuse it. You don't constantly have to put your name or your age or whatever other details are required. And you permission what of your personal data any particular app can have. Now, these data accounts have processing power, so they're a bit cleverer than just a simple Dropbox. And we have something we call the Smart Hat Engine. Now, an application to think about here is when you buy insurance, you might fill out dozens of different forms or use a comparison website where, again, they're getting your data. But here, the insurance company can send their algorithm to your hat, and it can do an analysis of your personal data to work out the risk in whatever that insurance might be, and then offer you that and say, look, This is how much your insurance is going to be. If you accept, it just sends the minimum required data back to the insurance company and you can make your payment. If you think about the sorts of data that you actually need, we always look for minimal viable amounts of data to be transferred. So for instance, when you go into a pub, the only data they need to have is you are over 18. They don't need anything else.